Time is money. Lucky for us, PTV Vistro is packed with powerful tools and features to save you tons of time building your network. With Vistro, you can quickly build a network of signalized and unsignalized intersections and roundabouts. In this two-part episode, I will show you how to apply global settings to your network and how to rapidly drop intersections and build a network. We will also take a look at basic intersection setup parameters for each intersection type. Before we begin coding our network, let's take a look at global settings. These settings are essential because new intersections created use these values as defaults. Ensuring that these values are correct in the beginning will save you lots of rework. Before we begin coding a new network, as I mentioned in episode 2, part 1, it's a good idea to set up your agency's preferred global settings and print report settings in the base model. When edits are made to the global settings in the base scenario, the edited values are applied for all new network objects, including in the copied scenarios. After setup, hit that Save As button to make a template file. In the template file, hit Save again, this time with your project name. Let's go over the global settings in more detail. Under the Edit menu, select the Global Settings. Here, we can set Vistro's default language. Let's set it to Russian. See anything different? Next, we have Location Settings. Here we can set the driving rule for your country with right or left-handed traffic, as well as imperial or metric units. The next series of settings are the default analysis methods for signalized, unsignalized, and roundabout intersections. Hey Canada, make sure you set signalized to the Canadian Capacity Guide or CCG. Next, we have intersection settings such as lane widths, speeds, right turn on red, and roundabout splitter island settings, followed by default volume settings and factors. And the remainder of the settings are for signalization. The next group sets the major flow direction, which is used for HCM calculations and defining the NEMA 2 and 6 phases. The following fields set the NEMA phase scheme, default orientations, and left turn lead lag settings. Next we have general signal and coordination settings, followed up by main phase and clearance phase minimums for vehicles and pedestrians. We have local settings for the CCG right turn pedestrian formulas, and lastly, a setting which controls the display of the approach cardinal direction. When this is set to preferred main direction, approaches will default to the 4 main cardinal directions, while main and secondary directions will display up to 8 subdirections. Next, let's drop some intersections. Use the intersection button on the Network Objects toolbar and we can place unknown, stop-controlled, signalized, and roundabout intersections. Looking to increase your productivity on your next traffic study? With the built-in Bing Web Map, coding can start right away. Just zoom into your project area and drop your first intersection. And unlike other software, Vistro's smart leg grips allow you to quickly web together a network of signalized, unsignalized, and roundabout intersections. With this efficiency, you'll have plenty of time to focus on the other important details. Vistro has a selection of signalized, two-way stop control, always stop control, and roundabout intersections. The last intersection type, unknown, can be used for those dummy nodes to generate more complex conditions, such as for jug handles, diverging diamonds, and spuies. To speed up the process, you can first create template intersections and set up details like signalization. Then copy and paste to similar locations using Ctrl-C and Ctrl-V, or right-clicking to access the context menu. Connecting intersections is simple. Just grab the leg grip points between junctions and connect legs together. Need curvature? Once connected, you can quickly fit your geometry exactly with any number of intermediate polypoints. Adding curvature can be achieved without the trial and error process of twisting two bending points or adding bend nodes. Best of all, these polypoints will automatically import into Visum and Visum. To add a polypoint, right-click to access the context menu, or simply left-click and drag on the dark blue highlighted leg. Polypoints can be deleted by right-clicking on the point to open up the context menu.
Finally, let's take a look at the basic intersection setup parameters for each intersection type.
Each junction type has a specific set of intersection parameters needed per calculation methodology. These can be accessed on the Intersection Setup tab in the Workflow panel. Common between all junction types is the intersection number, name, control types, analysis method, street name, and an option to show the street names. Completing this information is a good idea if you plan to copy and paste this intersection to other locations. This will save you lots of rework. With the Showing Street Names toggle, it may not be important to show the names at every intersection. Therefore, select this as needed. Turning on the Street Names Network object will display the names. And remember, under Global Settings, street name font heights can be updated. Next, the user can select the lane configurations. Select a predefined template or use the plus and minus buttons to add or subtract lanes. For signalized intersections, the intersection setup settings depend on the analysis method selected. The most basic analysis is the ICU method. Here you can enter the percent grade per approach direction and channelized right turn details, as well as how the channelized area is controlled. You can also select the radius of the channelized lane. Also, if an approach utilizes right turn on red, that can be selected here. For the HCM 6th edition, most of the additional information is for pedestrian and bicycle facilities, as well as parking. Specific details regarding these parameters can be read in the HCM. For the CCG 3rd edition, specific parameters such as turns on inner green, PCU length, and transit analysis details can be found. Again, specific details can be read in the CCG. For roundabouts, the data entry workflow panel is the same for the HCM 6th edition and Kimber. In addition to the general settings, specific roundabout geometry parameters, bypass lanes, circulation speeds, and splitter island configurations can be found. While the HCM 6th edition can be referenced for details on these parameters, the Vistro help lists a description of node geometry for the Kimber method. And finally, for all-way and two-way stop-controlled intersections, the basic geometry information listed is the same as the signalized ICU analysis.
It's so easy to code your network with PTV Vistro and set up your various intersection types. Join us next time for part 2 of this episode to learn how to enter your volume details and create your traffic signal controller.
Please subscribe so you don't miss a moment of this web series. If you have a comment or a Vistro question, please connect with me on the LinkedIn PTV Vistro forum. Streamline your traffic engineering or transportation planning study efforts with PTV Vistro.